Hi, everyone. I'm just going to get us started so we can make sure we're all on time. This is Isabel from Wisconsin Land and Water, and thank you for joining us today. As you just heard, I am recording this webinar, and it's going to be posted on the Wisconsin Land and Water website at some point in the future. And then I will also be sending everybody who registered a link when it is available, as well as a link to the evaluation and a request for PDH hour if you would like. So today our presentation will be Wisconsin DNR Technical Standard 1072 horizontal directional drilling, and our presenters will be Amy Mincer from DNR, Jerry Redermacher from DNR, and Mike Hackle from Hamburg Contractors. We're going to be taking questions throughout the presentation using the chat line, which is on the bottom toolbar, and you can submit a question at any time, and we'll try to get them answered as soon as we can. And then we're also going to open it up for a larger Q&A at the end for any lingering questions y'all might have. And so I guess without any further ado, Amy, Jerry, and Mike, please take it away.
Sorry about that. It took me a minute to get my cursor over to unmute myself. So welcome. Today we're talking about Technical Standard 1072, and my name is Amy Mincer, and I'm a stormwater engineer for Wisconsin Department of Natural Resources, and stationed out of Madison, Wisconsin. And I do technical policy work related to stormwater, and also assist with construction site stormwater permitting for utility projects. Today, kind of our objectives are to help you understand the purpose of Technical Standard 1072, understand the framework, and understand kind of what we're looking for when you apply for stormwater permits for projects that disturb more than an acre. And so to start out with, the technical standard is a very specific document intended to implement the performance standards for construction site erosion control and post-construction stormwater management. And this particular technical standard is focused on construction site technical standard. So it's intended to provide a path for stormwater compliance, permit compliance for most projects. We can't design it for every project. And it is not intended to be a comprehensive design guide or even a comprehensive guide to everything you need to know about protecting the environment. It's simply focused on runoff related impacts. And it's also, for our technical standards, they're not requirements. You always have the option of proposing something that would accomplish the same thing. So that option is always there. So what is horizontal directional drilling? Well, it's a trenchless method of installation typically used for pipes, conduits, cables, and cable bundles. And it's usually used to avoid or minimize superficial impacts to wetlands, waterways, roads, and other surface features. It can range from 1/2-inch diameter as high as 60-inch diameter, and usually runs about 40 feet to 3,000 feet in length, but can go even longer than that. You'll see the red dimension there of drill path, and that is a term that we'll be using throughout. And off the left is a picture of something you may have seen in your neighborhood that represents a small drill path going in. The method uses drilling fluid for a number of purposes. One is to keep the hole open. Another is to lubricate the drill head. And a third is to take that material that the drill head is cutting out and bring it to the surface. So that's the returns, and the solids are called cuttings. And the drill fluid is usually over 90% water, and the bulk of the rest of it is bentonite, but there may be specific additives used to help the drilling fluid serve its purposes, and to also help keep the drilling fluid within the hole. So these are pictures of what we like to think that the drill path is going to look like. And a lot of times it does, but occasionally you have what's called an inadvertent release, or IR, which is also known as a frac-out or an inadvertent return. And it's just an unplanned release of drill fluid. But that unplanned release can have some water quality concerns, primarily turbidity and sedimentation. But depending on what additives are used, there can also be a reduction in oxygen in the waterway, and in a small portion of cases, there might be potential for aquatic toxicity. So, and the other concern with it is that as you get into larger and larger diameters and longer drill paths, the work areas get more significant, and so there's a greater need for erosion sediment control around the work areas. So in terms of the purpose of an application of this applies to horizontal directional drilling, except for service laterals that are less than 6 inches in diameter and less than 200 feet long. And it's really focused on preventing runoff from moving disturbed dirt and construction materials from the land into the water. So there's erosion sediment control, and then there's 2 ways that we prevent drilling fluid from getting moved into the waterways via runoff. One is to reduce the risk of having an inadvertent return in the first place. And the second is to have a good plan to contain it quickly when we cannot prevent it. The focus of this technical standard is really on projects that would require permits. It does not create any new permit requirements. It simply identifies a path to address requirements of permits that the project may already need to meet. And again, this is not intended to be a comprehensive design guidance. Now I'm going to turn it over to Jerry Rademacher to talk about the next piece.
Good morning, everyone. Thanks.
Oh.
Can you hear me okay? Can you hear me okay?
Yes.
Yes, we can.
Okay, somehow I was muted. So I'm Jerry Rademacher with DNR. Good morning, everyone. So the HGD tech standard is kind of designed to what we say, plan the work and work the plan. And it's structured to review a drill path in kind of 3 distinct phases. We have that initial design phase where we're identifying resources, identifying project challenges on a more desktop method or through a desktop perspective. Then we have the planning phase where the project proponent is confirming resources, confirming challenges, and then kind of establishing procedures to address resources and challenges. And then the third phase is the construction phase, and that is just that, it's construction or the HGD itself. And really, if you're following the procedures that were previously established, then the potential of an IR should be limited, should be minimized. And if an IR does happen, the project proponent is kind of better equipped to respond to that release and minimize impacts to water resources. The HGD tech standard utilizes a size-based approach or size-based criteria per drill path. Larger product diameters and longer drill paths are going to have more fluid volume, higher pressure, more surface area within the hole. And because of those factors, they're more likely to have a release. And we're really focusing on the whole point of the tech standard is kind of focus efforts on those maybe projects that are higher likely to have a release or project areas that have higher quality resources. And as Amy said in the past, even though we have the size-based criteria, those service laterals that are less than 6 inches in diameter and less than 200 feet long, the tech standard doesn't apply to those cases. So we do have the project versus the drill path. Over your overall project area might have multiple drill paths, right? And typically speaking, that product diameter is probably going to remain pretty consistent without your project area, but the length of the drill path might change depending on, project specifics. Maybe a resource is longer, or, for whatever reason, your drill path might increase or decrease in length, and that might put the project or the specific drill path in different size criteria. And once again, the focus is putting effort on where it makes the most difference and really focusing on the areas where we're maybe more likely to have some type of release and or areas where there's that higher quality resource. When reviewing an HGD site, it's important to keep in mind we're not just looking and focusing on the drill path, but obviously we're also looking at kind of the HGD site as a whole. So the drill path, the entry and exit points, pipe assembly, pullback areas, lay down and staging areas, access areas, those are all kind of pieces of the HGD site that should be considered and factored in when we're doing reviews. So when looking at and reviewing the tech standard, the first phase, as I talked about, is that initial design phase. And with that initial phase, that includes a desktop review of water resources. So that desktop review of water resources, we're looking for navigable waters. If there are navigable waters, we're looking to see if any of those waterways have certain designations. We're also reviewing for wetlands and then key types of wetlands. So depending on the size of the project, whether small, or size of the drill path, small, medium, or large, that will kind of dictate and drive what type of water resources need to be identified within the plan. So the great thing about this desktop approach or this desktop review is you can utilize the department surface water data viewer to do your desktop review of water resources. So I'm not sure if you're all familiar with the surface water data viewer. I'm sure a lot of you are. If not, you can go to the DNR's external website, dnr.wisconsin.gov. In the search bar, just type in SWDV, and the very first item that pops up is surface water data viewer. So the surface water data viewer is a mapping tool, a GIS mapping tool. So once you launch that mapping tool, you get a kind of a view of the entire state. And there are several ways to search for your project area. You can actually upload shape files into the surface water data viewer. You can search by lat long, township, section, range. You can kind of zoom in and out. So very easy to identify or find a project area within the state. Once you zoom in or find your project area, for that desktop review for water resources, all you're really going to do is turn on and off different layers that are within the surface water data viewer. On the right-hand side of your screen, that top view is just kind of your, I would call the typical view that pops up when you zoom in on an area. Typically speaking, the layer for surface water is turned on. Layer for roads may or may not be turned on, those base maps. But then I find it useful to put on an air photo right away. And then you can start your review by just clicking on different options on the left under the layer options. And I'll give you a couple of examples here. So here's an example of an HGD site. And this is one, maybe if you upload a shapefile, or maybe you're just kind of keeping in mind your whole HGD site. We turned on the surface water feature. So we see there's a surface water within the project area. And this next slide, just showing the ease of identifying these different resources. On the left-hand side, once again, on that layer feature, we can click on the ERW and ORW waters layer, and you can see that that waterway turned a darker blue color, so we know it's an ERW or ORW waterway, which you will utilize in the design phase of the standard. Once again, areas of special natural resource interest is a layer that you'll have to identify in that initial desktop review. Left-hand side again, under priority navigable waterways, you can click on the areas of special natural resource interest button. Going back to the surface water data viewer, it's important to note that you don't have to use the surface water data viewer as your mapping tool. It's a tool that's out there. It's available to everyone. It's easy to use. But if your company or your place of employment has their own GIS web viewer or website that they use or software that they use, and you have the layers from the surface water data viewer, feel free to utilize your own, I guess, your own GIS software to do this review. Just make sure that the layers that you have are up to date from the department. From a wetland perspective, from a wetland screening, once again, there's a mapped wetlands as well as a wetland indicator and soils layer. So from that planning perspective, you're assuming that the mapped wetlands and wetland indicator soils are both wetland. If you've already conducted a wetland field review, obviously utilize the most current up-to-date field verified data as opposed to what we have as a desktop mapping tool. But if you haven't done that field delineation yet, then utilizing this desktop approach is acceptable. The surface water data viewer also includes soils information. So once again, you can click on that NRCS soils data, and the soils information overlays within your project area. And there's actually a point identify feature, which you can utilize anytime you have layers turned on, and you just click on the feature and it tells you what that map feature is. In this case, on this slide, it's showing you that that map soil type is a Kingsville loamy sand, which is important to know because as you're planning, it's important to know, what type of soils are out there. From a planning perspective, there are certain soil types that are more prone to be in bogs and fens, and the tech standard does require that you identify peat soils within your project area, and this would be the desktop approach to how you would identify those peat soils. And now we'll turn it over to Mike.
Good morning. Thank you very much, Jerry. So I'm going to talk about the constructability aspect of looking at these projects and utilizing the tech standard. Constructability and risk review is a preliminary review to investigate and plan for site conditions and restrictions that may increase the likelihood of an IR or impact your ability to respond to an IR should one occur on a project. One of the steps that go through constructability are verifying access, identifying existing and proposed facilities, reviewing the path, reviewing barriers for monitoring and response. The reason for this step is to try and eliminate the need for changes once the project has started. So for verifying access, step one would be we want to verify that we can get trucks and equipment to the drill path while remaining within the provided easements or right-of-way for that particular project design. We also want to verify that we can get personnel access to the drill path for tracking the drill head and monitoring for IRs along the drill path as we're drilling for the bore. We want to also make sure that there is sufficient room within the provided area to install the required erosion control BMPs and to maintain those BMPs throughout the construction process. Step two is identifying existing and proposed facilities that are within that drill path. We obviously want to avoid interaction with existing dry utilities such as power, gas, and communications for safety's sake. But the most common conflict and potential for an IR is conflict with wet utilities. Storm sewer pipes are larger in diameter, creating a much higher probability of conflict, but also they provide a direct link for the drilling fluid into local waterways if there would be a conflict or intersection with that pipe during the drilling process. A similar issue exists with sanitary sewer and water mains because of their size. And there's also a large concern, especially with water main, that potential drill mud getting into the water supply would provide a contamination of that drinking source. We also want to verify that proper separation can be maintained from proposed facilities that are to be installed after this utility is installed. If this is part of a proposed development or construction project, we want to make sure that we are providing correct separations from the drill path from those future utilities. The next factor in constructability is reviewing the path for existing topography. Does the topography lend itself to the use of HDD? Or is there a greater risk of an IR because of the topography that we are going to be drilling through? Does the existing soil show evidence of movement or instability, such as slides? As you can see from the photos on the screen, on the upper right photo, if we were talking about drilling along this backyard, not only are we concerned about a potential IR vertically from the drill path up through the soil, but on a steep slope, we also have to be concerned about a horizontal IR coming out the side of the hillside. The pressure and the drill mud is going to seek the path of least resistance. And if that soil is weaker out the side, that's where you potentially need to be monitoring and watching for those IRs. And then obviously in that other photo, if we've got soils that are showing evidence of movement prior to any construction starting and instability, we need to be concerned about the viability of utilizing HDD in conditions like this, because obviously the drill hole will not hold, and we'd be greatly concerned about IRs coming up through soil that had this much movement to it. The last major factor of constructability is looking for barriers in the ability to monitor it during construction, as well as barriers for responding during construction. Are we crossing a wetland or open water? If so, these are problematic for monitoring because we can't see the surface below the water elevation for monitoring for an IR. And it's also very, very difficult to respond to that IR and do the proper cleanup when it's under a wetland or an open water body. Is the crossing through a wooded area? That wooded areas do not provide resistance for monitoring because we can walk through it and monitor the drill path as we're going along, but it is problematic for response because it limits the ability to get equipment and materials to the IR area for cleanup of that IR. These types of environment and topography may be the entire reason why HDDs was selected and utilized, but they can also be the largest challenge for responding to and properly cleaning up IRs in a given drill path. Remember, the whole reason for this standard is pre-planning bores to limit the risk of IRs and be more prepared to respond to IRs should they occur. The next main task to limit risk on an HDD project is identifying the subsurface conditions. Because of the nature of how HDDs are performed, understanding the soil types that you are drilling through is imperative. And evidence would be that photo above. If you're drilling through this many cobbles, there's going to be a lot of limitations and risks associated with that IR. Some of the subsurface conditions that we're looking for are cobbles and boulders, as evidenced in the photo. High gravel content in soils is problematic for HDD because of it provides a more porous open path and less pressure resistant for the drill mud to reach the surface. Karst features or highly fractured bedrock are also incredibly problematic because we can have releases into those open caves or karst areas without knowing about it, obviously from monitoring on the surface. The only way you'd know about it is through monitoring your pressures at the drill and keeping an eye on that. So it's nice to know ahead of time if we're potentially drilling through areas that may have those soil features. Aquifers are obviously an issue. If the drill mud finds its path into an aquifer, that has the potential to cause great issue. Shallow groundwater and also shallow bedrock are also instances that we would want to know about ahead of time, more so for the ability to perform the HDD process rather than risk of IR. We have three main varying methods as to how we can gather that geotechnical data for a project. There's the desktop review, site visit, and geotechnical investigation. We'll utilize this data to modify the design or drill path and possibly avoid these areas. If we find that these soil types are going to be greatly problematic to HDD drilling, we may choose to modify how the project is built, either the direction that the utility is going to be run or the method that's going to be used to install it. But we also know that we may need to increase the amount of monitoring that we do depending on these soil types. If we know that we've got a site with a high gravel content, we know that we're going to want to be more vigilant in our monitoring than if we were in a site with extremely tight clays that would have a much less risk of an IR. In extreme circumstances, it may even change the overall design of the project, and we're going to find an entirely new path rather than trying to force it through surface conditions or subsurface conditions that are unsuitable for utilizing HDD. First step, as Jeree mentioned earlier in the design process, is a desktop review. We can do a very similar task for constructability. We can look at our previous, as a contractor, a previous site experience. If we had installed utilities or other features on that site in the past, we should have some understanding of what those soils are like. We can look at historical boring logs from other projects that were done in this same location or adjacent to. We can look at those soil borings and understand what kind of soils we would have in that given location. We can look at neighboring properties if they had projects that were done as well. We can look at the Dane County soil maps, as Jeree talked about earlier. County soil maps provide a very good indication as to what potential types of soils you would run into. We can also look at existing well maps that would give us an indication of underground aquifer elevations, as well as potentially groundwater elevations for those borings. And last of all, we can gather a lot of information from just simple aerial photos that are available on various browsing sites, or also street views that can give us indications of what is in that area. Next step would be a site visit. What we want to do here is visit the site and visually investigate what features we can see with our own eyes that might give us clues to the soil types that we could encounter. Do we see rock outcroppings? Do we see a neighboring construction site that has disturbed soil with stockpiles that can give us a clue to the types of soils we may be working with? Are there surface waters, ponds, streams, or rivers that are going to give us indication of whether or not that soil is holding water? All of these provide methods of potential reviewing the soil types without completing a full geotechnical investigation. And that, of course, is our next step, potential possibility, is to complete a full site-specific geotechnical investigation with borings or test pits and a written report talking about what kind of soils we could encounter along the way. These are required for medium and large drill paths. When Jerry showed that chart earlier indicating what the 3 various bore types that we've established in the standard. We'd want to make sure that we're doing this soil investigation slightly offset from the drill path so that our drill path is not intercepting these now weakened soil areas from the test pits or the borings. And we'd want to make sure that, understanding that when we're doing these borings, if we encounter soil types that are going to be challenging for the HDD, we may want to do additional borings to further understand what those soil types that we investigating are. And as the quote there says, we can never have too much soils data when we're talking about working with underground and interacting with the soils. A much more in-depth way of analyzing this drill path would be a hydrofracture analysis. And these are used when we're talking about extremely large drill paths. And a simple explanation is it's the difference comparing the expected drilling fluid pressures compared to the confining soil pressure of the soil around it. And this gives us another way of analyzing whether or not we can anticipate IRs because of the soil and the proposed drilling methods. From here, I'll turn it over to Amy to discuss permits and plans.
Thank you, Mike. So the next thing to talk about is drilling fluid requirements. In order to cover projects under general permits, we need to know that they're protective of waters of the state, and groundwater is one of the waters of the state. So there's some requirements. We've been working with our drinking and groundwater program to have some requirements for drilling fluid. So to start with, water from a known safe source, similar to drilling other wells, and to document that source in case in case an issue comes up, we would possibly ask for that information. So it's good to have it documented. The other piece is to only use pre-approved products. By code, anything that's on the NSF 60 health effects list is presumed to be pre-approved. There's also an approved drilling and filling sealing products list, including heat exchange drill hole products list on the website under well drilling. And then we're developing a separate pre-approved list for products that are only used for HDD and wouldn't have been reviewed for those other 2 lists. But there's essentially 3 lists that one can use products off of. And we are asking all projects with medium and large drill paths to disclose what drilling fluid additives they plan on using. There is a possibility of submitting an amendment should that information change. So our drilling fluid product reviews for HDD specific products are, the process is similar to our well drilling product reviews and requires disclosure of any ingredients that we have water quality criteria for groundwater for, and anything on our health department website for chemicals that have potential human health effects. We can maintain ingredients as trade secrets if necessary. We just need an application according to code. And we do have a pre-approved list on our technical standards page. If there's something you want to use in addition to those, please request that in advance. Next thing is minimum cover. And here is where another place where the focus of the technical standard and the scope kind of limits what we say. So these are minimum covers under water resources, and these are for inadvertent return prevention only. Additional depth may be needed, particularly if there's evidence of scour or erosion to prevent future exposure. So this is really only looking at one factor for minimum cover. There may be reasons to go deeper. Occasionally, there might be a reason such as a utility conflict where there's a need to go shallower, and we just need an explanation for why. When you have a project that disturbs more than an acre, there's information that we're going to want to see at permitting. And some of these, there may be different utility companies have standard procedures, and where we don't need site-specific information, those can still be used. But we're looking for a summary of the HDD operations, a spill plan, and an inadvertent return plan. The HDD summary is really communicating to the regulatory agency what you're doing, where you're using horizontal directional drilling, what sort of risk factors exist, and what you're going to do about them. So any small drill path that crosses exceptional resource waters or outstanding resource waters should be listed. And that's really primarily for projects that disturb more than an acre, because we need to know that information anyway. And then all medium and large drill paths should be listed. Any other small drill paths would not need to be listed. And as mentioned earlier, service laterals that are less than 6 inches and less than 200 feet long are exempt. This is a kind of a snapshot of a tabular summary that would have the sorts of information we're looking for. So location, in this case, we've listed it as a station. the starting station or something. So basic size information, water resources, and risk factors. That lets us kind of quickly focus our review time where it matters the most. And then risk management factors. So for each either drill path or groups of drill paths that have similar characteristics, we want to know, okay, what's causing the additional risks and what are you going to do about it? We're not dictating specific measures that have to be taken because those are often very site specific, but we do have a lot of items in the considerations section that are measures that could be taken to reduce risk. And certain things that you may do to reduce risk, such as doing a hydrofracture analysis. If you do it, there's certain information we'd like to see that gives us more information of what you've done. For medium and large horizontal directional drill paths, we'd like to see the geotechnical report. We'd like to know what disposal options the contractor will be given as far as what they're going to do with the drill fluid and cuttings. And there's some notes here on this slide from conversations with our wastewater and waste programs. But the drill fluid disposal is typically regulated by the wastewater program under a dewatering operations general or individual permit. But if the HDD goes through contaminated soils or sulfide deposits, that may need to be landfilled. We're looking for a site plan, and for large drill paths, we want to see a profile. And in the attachments, there's a figure showing the sorts of things we would hope to see on the plan and profile. Spills prevention, containment, and response. This is really kind of focused on material storage. I'm not going to focus too much because this is something we routinely see in our applications already. Just note here something I found on our spills website, that one of the biggest issues with spills is petroleum products. So as you're doing the spill plan, thinking about how to prevent spills when you're fueling equipment. The inadvertent release plan is focused on having a solid plan before you go in, but before you start drilling, so you know how you're identifying an inadvertent return, what your short-term response is, long-term response. Your crew should know, the construction crew should know what's expected of each member and what needs to be done to contain the drilling fluid and get it cleaned up. So some elements of that inadvertent release plan include training, equipment and supplies on site and on call. Please note that silt fence is not a good option for containing bentonite. It's not designed to filter out particles of that size. What you're doing for inspections and documentation, a plan for access for so if you have an inadvertent return, do you know how you're going to access it? Who do you need to notify? What are the long-term and short-term cleanup actions? How do you who is going to decide when to start drilling? How are you going to make that decision? And what are the long-term restoration plans? But the basic concept of the inadvertent return plan is to not wait until you have one to make decisions about how you're going to respond. Attached to the technical standard are some size-based tables. So if you have a project that's all small drill paths, you can just go to that table and it'll list out which things need to be done for small drill paths. If you have one large drill path in your project, for that drill path, you go to that table. And then we have some figures, which I think I showed you the sample plan profile earlier. Now I'm going to hand it over to Mike to talk about construction.
Thank you, Amy. So the last portion that I'm going to discuss here is construction criteria related to the standard. So the construction criteria focus on pre-construction meetings, site observations, monitoring and inspection, and is finally reporting. So for pre-construction meetings, the purpose is to get everyone on the same page as it relates to the environmental controls for the given project. This should be done prior to mobilizing and the beginning of construction. It can be done in an office or on site, and it's only required on the medium and large drill projects, but we recommend it on all projects. The attendees on large projects are required to be the owner of the utility, the general contractor, as well as the drilling contractor and environmental representative should all be present for this meeting. Topics of discussion would be the location of resources that need to be protected throughout the course of construction, the plans for how you will be protecting the environment during construction, the limits of disturbance for all the various components related to that construction, not only the actual drill path, entry and exit points, but also any access points, staging areas, and drill string areas. Spill plan and the IR plan need to be gone over at this meeting, depending on the boring size. You also want to talk about who's going to monitor for IR along the drill path, and then also the responsibility of who's going to be reporting throughout the course of construction. You also want to discuss the communication chain of command in terms of who's going to be notified should there an IR happen. And then the last topic would be discussing the restoration to complete the project back at the site back to its original condition post-construction. For site observation, this meeting would be the interested parties should all meet at the drill path location prior to starting actual construction. For small drill paths, a separate pre-construction meeting is not required. This on-site meeting would serve as both the pre-construction and site observation meeting for any smaller drill path. This occurs prior to the drilling starting. We want the drill operator and the drill path monitor must physically walk the drill path during this meeting for all project sizes. Owner rep and designer rep would only need to be present for large drill path projects. If the project's crossing an Anzanari waterway or a wetland, then an environmental representative for the project must also attend this project meeting prior to starting. For monitoring and inspection during the project, once construction has commenced, then we would begin to talk about the monitoring and inspections happening on that project. We want to make sure that we're monitoring the drill path for IRs or any indications of a potential IR throughout the entirety of the drilling process, beginning with the pilot hole and all the way through the final pullback of the carrier pipe. The drill contractor should be logging drill fluid losses and gains throughout this entire process as well, for reference during construction as well as after. And on large bores and bores that cross resources, you also must have an environmental representative inspecting the site at least once daily to verify the monitoring and reporting by the contractor, as well as to also walk the drill path and do their own investigation for potential IRs. And the last step would be reporting during the construction process. If requested by the DNR, you'd need to provide regular status reports on the following items: the HDD drilling status throughout the bore and pullback process, must report any spills and inadvertent releases. You have to report any significant fluid losses or gains throughout the drilling process, and you must report the volume of any fluid that would be captured during response and cleanup of an IR. And last of all, Amy will wrap this up by discussing the considerations from the standard.
Thanks, Mike. So within the considerations section, there's a couple different categories of things to think about. There are some considerations that relate to resource protection, and the only reason they're not criteria is that would be out of scope for the technical standards. So they're in considerations to provide reminders that whatever environmental commitments that you've made, you need to follow through. There's also implementation considerations that can be used to adjust to risk, address winter work, and a number of other areas. And then there's some information on geophysical investigation and hydrofracture analysis. These are not requirements, but these are recommendations from the team of experts that we assembled to develop the technical standard and those that commented on the technical standard. The technical standard can be found at our website. If you search for stormwater, there's this box you'll get on the stormwater page called technical standards. If you click on that, you see this page. It's under this first item, stormwater construction technical standards. And this is one of many technical standards. There's information on perimeter control, dewatering, and quite a few other measures that you should be considering during construction. And this is the list of our technical standard development team. And at this point, we're going to take questions. I see that there are a number of questions that relate to a specific project for which an environmental impact assessment is currently underway. They're working on responses to comments. And so since those responses are being developed, I don't want to address questions and comments related specifically to that project. This technical standard is more broad than that, so I'd kind of like more broad questions.
Thanks, Amy. I have pulled out a couple of questions that I think are relative to the standard, but because there are so many comments more specific to the, a specific site concern, I thought maybe you could review again the difference between a standard and a permit. You kind of touched on that in the beginning, how the standards tie into the erosion control process, but maybe that would be helpful to understand that delineation here.
Yeah, so the technical standard is really a framework to set people up for success in meeting the permit requirements. And it's really targeted to typical projects. It's not intended to address every single aspect that may need to be considered for highly controversial projects. A lot of those issues are going to be addressed as part of an environmental impact statement. And we're kind of walking a little bit of a tightrope, because for the technical standard, we're wanting to have enough requirements to be protective of the environment in terms of protecting the environment from HDD and the things that can go wrong during the installation. But we also don't want to be so restrictive that HDD is not used where it could be successfully used to avoid environmental impacts. So it's kind of like if you're too restrictive, you're going to impact the environment, and if you're not restrictive enough, you're going to. So we're trying to maybe come somewhere in the middle with this.
Great, thank you for summarizing that. Some of the technical questions I think were answered in subsequent slides, so I won't reiterate those here, but I do see a few that maybe you could go into. One of them is related to surface water data viewer. Jury, are you still on, or did she have to leave already?
I think
No,
she had to sign off.
Okay, so I guess the question was, how user-friendly is this surface water data viewer information specific to import into a CAD system? Is that something either of you know, or perhaps someone else on the team? I know you have some familiarity.
I know that the data that is viewable on the surface water data viewer is also available as in GIS format, and those can usually be imported into CAD programs.
Okay, thank you.
I don't know if somebody else on the team wants to speak to that as well.
Yeah, I know, for example, Anne is here, and I know she has a lot of familiarity with surface water data viewer.
I'll just weigh in that I know we stream the data into our GIS program so that it's always live. And that would probably be the one question as far as bringing it into CAD, if you would have to download the files as shape files, for an example, and load them into CAD and kind of update that regularly. I'm not sure if there's an option to stream it in like we do for our GIS programs, like Esri.
I see. I guess, Mike, you mentioned a little bit about the monitoring and reporting section, but there was a question about whether there would be an independent environmental monitor in any situation. Could either of you speak to that level of detail?
We require a environmental monitor for large projects, but we do not differentiate between independent and whether they're and hired. They would be essentially working for either the design team or the contractor. And I did see we did talk about, as far as the question for reporting, you've got 24 hours to report an IR based on the standard. And the required information to provide at that time is the amount of fluid that was lost or gained and the amount of fluid that was recovered during the response.
Okay, yeah, thanks, Mike.
I would add to that on specific projects, our Public Service Commission or under a wetland and waterway permit, there may be requirements to have independent environmental monitors for specific projects.
Okay. Going back to the question about the surface water data viewer input, somebody in the audience actually answered that question and said that shape files can indeed be obtained by using the information tool to grab the shape files for that area. So it is possible to use it into CAD as well as Anne mentioned, the streaming into GIS. There's another question, I think, related to the surface water data viewer. How do you account for shifting floodplain boundaries?
I think that's something where whatever the currently adopted floodplain boundaries are the ones that would likely be on the surface water data viewer. But I know that that is an ongoing process. And it's something to be aware of. Really the most important piece is knowing where the floodway is and being careful to not have anything there.
Okay. Let's see, there's another user looking to find out, I think Amy, you mentioned a lot about the IR plan and what the steps are in the event there is an IR. And this is kind of a specific question. Are there requirements for water testing of water bodies to determine contaminants after an IR?
We do not have that in the stormwater permit. But I don't know, that could be something that's a consideration for a wetland individual permit. And just a word to an earlier comment that was more directed at a specific project, but thank you for the information on the seminar for Wednesday. That is of interest to me, so thank you for that.
There's a follow-up question here about those changing floodplain boundaries, and I realize this isn't quite your area of knowledge, but this person is asking how would that be documented in a remote place?
I think the floodways are typically identified as part of FEMA floodplain mapping. So in a place that doesn't, in communities that do not participate in that program, there might not be a delineated floodway. So I don't know, in remote places, it's going to depend on whether that community participates in the flood protection program or flood insurance program, I think, through FEMA.
Okay, so if you're good with that answer, Amy, I think we are just about at the end of the time we have for overflow with questions. So thank you so much, both Amy and Mike, for sharing all of this with us and presenting today. Just so everybody else knows, I will be sending out the links shortly after this with the recording, the evaluation, and the PDH requests, and any resources, including the PDF of the slides. So thank you for coming today and have a great day.
Yes, thank you.
Thank you, Isabel.